4.4, Part 1, Properties of the Definite Integral. Okay. Identify the limits of integration in the given definite integral. 0 and 6. How hard is that? Right? I mean, you're integrating from 0 to 6. There's nothing else to say. Here you're integrating from 8 to 9. Identify the integrand. Oh man, I mean, I guess that's the function. I've never given it a name. But there we go. Alright. Which of the following is the integrand in the definite integral above? It's square root of t. Super. These are easy. What is the variable of integration? Ooh, it's y. You're integrating with respect to y. U is just some constant. Alright, so I must know my way around the integral then. I can move on to the next objective. What is the net signed area between this function and the x-axis over the interval of -1 to 9? Well, let's draw a picture of it. So, change colors here. I need to plot the function x minus 7. That's a function that has a y-intercept of 7, negative 7, and a slope of 1. So this is my function, because that's minus 7 right here. And they want the net signed area from -1 to 9. So it's the net signed area, and all that means, well, that just means integrate. If I just integrate from -1 to 9, x minus 7, then I'm going to get a negative number, because the part that's below the x-axis is way bigger than the part above the x-axis, so it'll result in a negative area. Right? This will be 1/2 x squared minus 7x evaluated between -1 and 9. So you would have 1/2 9 squared minus 7 times 9. Take away takes away come on, take away 1/2 of a -1 squared minus 7 times -1. So that would be 81/2 minus, and then 7 times 9 is 63, and then minus a 1/2 plus 7. Okay. Using my calculator then. You get minus 30. Now maybe they had an idea for you to just solve it with some geometry, which is possible here. Because the length of this leg is 8, and the length of this leg is 8. It's half of a rectangle. It's half of an 8 by 8 square. All right? Actually, let me write it down here. This area right in here is 64 over 2. So 32. But it's below the x-axis, so... Now what you want to bet the area of this is just going to be 2. Yeah. This distance here is 2. Alright, that's this distance. This distance here is 2. It's a half of a 2 by 2 square. So it's half of 4, which is 2. Add those up, you get negative 30. Okay. Given this function, minus 2x, find the net signed area on the interval from minus 4 to 9. Okay. So it's a line that goes down like that through the origin. Goes through the origin. And I didn't include near enough space, so let me attempt to fix that. It's a shoddy attempt. We'll call this, I guess, 9. And that means that negative 4 would have to be like right there. Once again, I'm going to get a negative number. I know that this triangle down here has a base of 9 and it has a height of 18. It has a height of 18 because this function is a minus excuse me minus 2x. So then right there is minus 18. Gosh. So it's half of a rectangle whose sides are 9 and 18. Here you will get minus 81. For the other piece, that side length is 4, and this side length would be 8. It's half of a 4 by 8 rectangle. So it's half of 32, that's 16. Minus 81 is our answer. You get negative 65. Now, where this is going is towards the fundamental theorem of calculus, which says that I can integrate from minus 4 to 9 of that function. x squared. But you'd be evaluating between minus 4 and 9. And then you would put in the top number minus the bottom number. So there it is, evaluated at 9, and then take away what it is evaluated at negative 4. And you would have a minus 81 plus 16. That's the same thing that we had. So it's negative 65. What is the total area between that line and the x-axis on the interval from 0 to 5? So what they would want me to do there is, even if it dipped below the x-axis, I should not have that area be negative, right? That line had a y-intercept at minus 7, had a slope of 2. So then this is my function, 2x minus 7. Where does it cross right there? Well, that's where the function takes on the value of 0. And that would be at 7 halves. And then I guess way over here is 5. So I want to find this positive area plus this positive area. Okay. Well, how tall is it right here at 5? That would be, it has a height of 3. You put in the 5 for x, you get 10 minus 7, that's a height of 3. And this width right here is just 5 minus 7 halves. So it's 10 halves minus 7 halves, so it's 3 halves. 3 halves by 3. That's half of a rectangle with sides 3 halves by 3. That's this area. And then this rectangle has a side of my drawing's really out of perspective here, isn't it? I'm gonna make a new one. This is minus 7, so right, so then that right there is about 7, so this would be about 5, and that right there is 7 halves where it crosses, and my line goes like this. There, that's more in perspective for you. So that little piece this is the function 2x minus 7. So right here it has a height of 3, and it has a width of 3 over 2. So that's that area, which is just 9/4. And this area over here is just half of a rectangle with side lengths of 7 and 7/2. And so you get 49 over 2. Then all of this positive area together, the area of those two rectangles together, triangles together, is 53 over, or sorry, or this is not 49 over 2, it's 49 over 4. It's 53 over 4 is our total. I didn't do that right. It's not 53. It's 58. Which reduces to 29 over 2. All right. Cool. Okay. And we could have done that with fundamental theorem of calculus, but I guess we'll wait until we have to. What is the total area between this line and the x-axis on that interval? So there's minus 6. I guess right there is 3. And my line is 6x plus 6. So I ran out of room. Let me try again. There's minus 6. That's where it crosses at 6. I didn't really indicate the slope very well, did I? Okay. I'll plot some points that'll help me, as I want my drawing to be in perspective. Because having if I cross at 6 and have a slope of 6, well, that's steep, you know. So there's my line, 6x plus 6. And they want to know what's going on between minus 6 and 3. Well, 3 would be like right there, and minus 6 I guess would be like right there. And they want the total area. So I'm curious where it is 0. That's right at negative 1. Because if 6x plus 6 was 0, then we could solve that for x and get negative 1. And that means the legs of my triangles, this one is 5. That one has a base of 5, and this one has a base of 4, so it's still not a great drawing, but you get it. The height of this rectangle is, the triangle is f of 4, or excuse me, f of 3. How high up did it go at 3? It went up to 18 plus 6, so it has a height of 24. How far down did it go at minus 6? So that's a negative 36 plus 6, so this is, you know, that's minus 30 right there. So that makes the leg of this triangle be 30, with a base of 5, and then this one has a base of 4 and a height of 24. So it's 1/2 30 times 5 plus 1/2 4 times 24, and you get, oh boy, 150 divided by 2 is 75, and then 4 times 24 is 96, divided by 2 is 48. Altogether, 1, 2, 3. So that positive area, not letting them cancel, the positive area is 123. Alright, I'm not going to mess with drawing a picture on this one. I'm just going to do it by fundamental theorem of calculus. You need to get used to it anyways. The function is minus 2x minus 6. Oh, here they want the net signed area. Okay, great. Well, then I just integrate with, I don't have to do anything special. If I needed the total area, I'd have to do something special to my interval, which I was going to show you, but now I don't have to. So integrate from minus 8 to 5. So integrate from minus 8 to 5 of minus 2x minus 6. And then we'd have a minus x squared minus 6x evaluated between minus 8 and 5. So then you do the top minus the bottom. So it's a minus 5 squared minus 30. That's my top minus the bottom. You would get minus 64 plus 6 times 8, which is 48. And so, let's see. We get minus 25 minus 30. So that's minus 55. Plus 64 minus 48. I get negative 39. Naturally, you can draw those triangles if you wish. 75% complete. Here they want the net signed area, so that means we just let the areas cancel if they stick below the x-axis. That means you can just integrate between the limits without having to do anything special. You can just say the interval from minus 4 to 7 of a minus 4x plus 8. So it's a minus 4 over 2 x squared plus 8x, and it's evaluated between minus 4 and 7. So then I'm gonna put in my 7 there. I'm gonna put in my -4 over here. And that's the fundamental theorem of calculus, which I'm sure is coming up shortly. So this is -98 plus 56, okay, whatever that is. And then this would be -32 minus 32. Okay. So in the end, I'll have a -98 plus 56 plus 64. I get 22. Okay. I guess I should have been following the instruction. It says using geometric formulas. So we're obviously not to the fundamental theorem of calculus yet, but it does have that name, fundamental theorem of calculus. You are in a calculus course, so it is the most important theorem you can learn. I guess I'll switch back to geometry on this one. No, I'm not going to switch back to geometry on this one because they want the total area. Or maybe I'll do it both ways. So they want the total area, which means I'm going to get a positive number when it's done, no matter what. The function is 4x minus 10. So the picture of it's like this. There's minus 10. And it's a pretty steep slope. Okay, I'm gonna wonder where it crosses right there. Oh, it's 4x minus 10, sorry. It's going to be 0 at 10 over 4, or 5 halves. So you can't just integrate from -1 to 4. Because 4 is not way over there. Because 4 is 8 halves. So 4 is like right there. And there's -1. So our total area would be the area of this triangle plus the area of this triangle. We want these areas. And you can't just say integral from -1 to 4 of your function. That won't do it. That'll just give you the net area. The total area would have to be broken up into 2 integrals. I would have to, I can integrate from 5 halves to 4 of our function, and it would give me this piece. If I integrated from -1 to 5/2 of our function, it would give me a negative number equal to that. It would give me a it would give me a number whose absolute value is that area. So if I just stuck a negative in front of this, then that would become a positive value. And the addition of these two is the total area. So I had to break up my integral right there where it crossed the x-axis. With geometric formulas, this should be no sweat. It's you know, at -1 makes this side length be 14, and this other side length is 7/2. This one's 3/2, and it has a height of 6. Put the 4 in for x, you get 16 minus 10, so it's 6. Then 1/2 times 14 times 7/2 plus 3/2 times 6. That's my total area. It would be equal to this integral plus this integral evaluated with the fundamental theorem of calculus. This should say 7/2. So that's 49 plus 9. It's half of 58. I get 29. All right, getting close to the end here. Find the total area between the curve and the x-axis. So knowing what I know now, that I got to break up my integral into two pieces, then I know that my function, minus 4x plus 8, here's the picture. They want to integrate from -4 to 6, wherever 6 is. Where does it switch to start having negative area there? I don't want that to be negative because I want the total area. Where is that thing going to be 0? Well, it's wherever 4x equals 8, so that's when x is 2. So I should integrate from -4 to 2. When I integrate from -4 to 2, all that's going to be positive. That's going to give me a positive value. And then I want to add to that the integral from 2 to 6. There I've added that positive. So this is a negative number, and then I'm subtracting that negative, so I'm really just adding something, right? In other words, all of this is a positive number. Okay, then the antiderivatives are minus 2x squared plus 8x, evaluated between -4 and 2, minus a minus 2x squared plus 8x evaluated between 2 and 6. Okay, so this would be easy to do with geometry because it's just a line, but you know, later on you're going to have some crazy function and you're going to have to do it like this. Okay, top minus the bottom. So here you'd have negative 8 plus 16. That's the top minus the bottom. So I put in my minus 4 and I get negative 32 minus 32 okay, there's that. And then top minus bottom over here, put in the 6, you get 36 times negative 2, so that's 72, negative 72, plus 6 times 8, that's 48. Top minus the bottom, so when I put in the 2, it's just going to look just like that. Okay. And there we are. Okay, I'll finish it up here. So it says to me, so this part right here is just 8. And then if this negative distributes, I'm going to have plus another 8. So those two together give me 16. And then this will be plus 64. And then this will be 24. So I get 104. Now who knows? Was that easier than doing it with geometry? I have no idea. To me it is. If you want to do it, if you need to do it with geometry, then you just have to draw a careful picture. So that way you don't mislead yourself. You can easily mislead yourself with an incorrect picture. Alright, that's it. See you in the next one.